We're going to be working with solving compound inequalities. Compound inequalities, defined here, are two inequalities that combine into one statement by the word and or by the word or. An and inequality will usually be joined together without the word and in it, in the format of the smallest number, a less than or a less than and equal to sign, your variable less than the big number. So that's the format of what the compound inequalities look like and how we formally write our solutions. Those are called intersections, and the graph actually looks like an intersection when you're done. Open or close circle depending on your inequality symbol, and it's kind of each line is going into each other, intersects as such. It'll be easier to see when I do an example for you, but I just wanted to preview this a little bit as well. Okay, and then the or graphs, the or inequalities, you'll know because it has the word or right in the inequality. So this is an or inequality because it says or. The one I highlighted in blue is an and inequality because it does not say or. It doesn't say and necessarily, but it does not say or, so it's not an or. Or inequalities must say or. And these are called unions. And on a graph, they're usually facing out, going out, but not always. I'll show you some. I'm not going to start with the word problem, so I'm going to jump to example 2. Solve each compound inequality and graph the solutions. Well, my first question is this an and or an or? And I know it's an and because it does not say or. So this is an and inequality. And the way that you solve this inequality is if you kind of pretend that that piece isn't there for a second. Normally you would subtract 6 from both sides of the inequality sign to isolate the x, right? Block off my x, subtract 6 from both sides. Well, since there's something there as well, I'm going to subtract 6, but I'm going to do it from this side of the inequality symbol as well as the other side. So if I kind of draw a line through these inequality symbols, you might know what I mean a little bit better. I had to do it to both sides of the inequality. That canceled, and now I have negative 9 less than or equal to 3x is still stuck in the middle, less than 12 minus 6 is 6. Okay, my next step to isolate x normally would be to divide by 3, the coefficient. So I'm going to divide by 3 on all sides. And negative 9 divided by 3 is negative 3 is less than or equal to 3, just kidding, x. 3x divided by 3 is x. Less than 6 divided by 3 is 2. Okay, so what this is really saying is normally we flip, so x is first, so you flip the inequality sign's direction, so x is greater than or equal to negative 3, and then also that x is less than 2. This is the and part of it. So x is greater than or equal to negative 3, that's closed circle going to the right, and x is less than 2, open circle going to the left. Now you can see that this is an intersection. These lines crashed into each other, they intersected. And that is the whole point of the and compound inequalities. So in set builder notation, I can say for all values of x such that negative 3 is less than or equal to x, which is less than 2. Okay, going back to the word problem, we have movie tickets for kids younger than 13. So if x is less than 13, and that's $5.95. Movie ticket for an adult 13 to 64 costs $8.95. And for senior citizens, 65 and older, so if x is greater than or equal to 65, it costs $5.95. Okay, it says to write and graph an inequality that describes the ages of people whose tickets cost $5.95, so the middle group doesn't matter to me. But if they're less than 13, or x is greater than or equal to 65, then their tickets cost $5.95. So on a graph, that would be open circle at 13. They have to be less than 13, not equal to 13. And 65 and older is including 65, so that's equal to 65 going to the right. That's what my graph will look like. And my compound inequality would say for all values of x such that x is less than 13 or x is greater than or equal to 65. Okay, let's try example B here. Again, I like to draw my line down my inequality symbols so that you can see I'm isolating this x, but I have a minus 10 with it, so I'm going to add 10 to all sides. That canceled that. Now x is by itself in the middle. Less than symbols back. Negative 9 plus 10 is 1, and negative 5 plus 10 is 5. So I get 1 is less than x is less than 5. I already know it's going to look, open circles at 1 and 5, looking like an intersection. Okay, otherwise I can separate these as two separate inequalities. The 1 is less than x needs to be flipped so that x is greater than 1, which is what's happening right here. Going to the right, x is greater than 1, open circle. And then my other inequality would have been x is less than 5, which is already with the variable on the left, so that's good. That'd be open circle at 5 going to the left, and you can see that they're just intersecting there. Okay, for the or inequalities, it's really just two separate math problems with the word or in between. So for my first math problem, I'm isolating this a, so I'm going to add 1 to both sides. I get 2a is greater than 14. To get rid of the times 2, I divide by 2 on both sides, and a is greater than 7. Okay, on the right-hand side, subtract 11 from both sides. Negative 6a is greater than or equal to negative 1 minus 11 is negative 12. Divide both sides by negative 6. I'm dividing by a negative here, so I have to flip my inequality sign. So a is less than or equal to negative 12 divided by negative 6 is positive 2. So remember, whenever we're multiplying or dividing by a negative, we flip our inequality sign. So my final answer is just a is greater than 7 or a is less than or equal to 2. So greater than 7 would be open circle at 7 going to the right, and closed circle at 2 because it's less than or equal to going to the left. And I can write this in set builder notation as well. So for all values of a such that a, usually write the smaller one first, less than or equal to 2, or a is greater than 7. Okay, and example B, got my or. 2 plus r is less than 12, so to isolate r, I subtract 2 from both sides, and r is less than 10. And on the right hand side, r plus 5 is greater than 19, subtract 5 from both sides, and r is greater than 19 minus 5 is 14. With an or in between, so r is less than 10, which is here, going to the left, and r is greater than 14, so I'll just add 14 to the number line. Open circle, going to the right. Set builder notation, all values of r such that r is less than 10 or r is greater than 14. Okay, to write a compound inequality for each graph. I know that example A is an or, and I've got x is less than negative 2, open circle, that's why it's just the less than symbol, not equal to, and the arrow was pointing to the left, so that's less than. Then this one, the arrow is pointing to the right, so that's going to be x is greater than, open circle again, so not equal to, 5. So that's my compound inequality. And for example B, this is an intersection. This is going to be an and compound inequality. So I need my small number less than or equal to x less than or equal to big number. Okay, so my smallest number is -2, but that was a closed circle, so I need equal to. And then my large number is 5, but that was open circle, so I do not need equal to. So my compound inequality is -2 is less than or equal to x is less than 5. And in set builder notation, that would look like this. Inequality